Jesse, whoever Jesse is making a tower using playing cards. This is row 1, this is row 2, and this is row 3. In row 1, requires 3 playing cards. So these are cards all put together to make a little triangle, okay? Guys, row 2, you have to put 6 more playing cards to get a second row, okay? How many playing cards do you add for the third row? No, hold on. Is it? Yes, it's 9. There you go. So every row you're adding how many more? 3 more. So on the 6th row, I would have 18. There we go. Perfect. Okay. Now, if we look at the same picture and I ask you for the number of triangles in each row. So row 1 has 1 triangle. Row 2 has how many triangles? 3. How many is row? So that's going up by? Perfect. We're adding 2. These are examples of arithmetic sequences. Okay? Arithmetic means you're adding something to get the next number. So in the first one, we're adding 3 every time we go up. In the second one, we're adding 2 every time we go up. Okay? There's other types of sequences. So for example, there's a famous one called Pascal's triangle. And it looks like this. If you start with 1, the next row has 1 and 1. Okay? Then, to get this number right here, you add the 2 numbers above it. Okay? 1 plus 1 gives you 2. 1s are always down the side. To get this number here, I add 2 and 1 to get 3. And then this one, 2 and 1 gives me 3 again. The next row would be 1. What number am I putting here? 4. And then 6. And then 4. And then 1. Now, we're not going to study Pascal's triangle. I'm just showing you there's different types of sequences. I want to show you something cool about Pascal's triangle, though. If I have x plus 1 all squared, remember we did this stuff like 3 weeks ago? That really means x plus 1 times x plus 1, which if you FOIL that out, you get x squared plus 2x plus 1. Okay? Right? Does everybody agree with that? What's the coefficient in front of the x squared? 1. So I could just write 1, 2, 1, which is that row of Pascal's triangle. So no, it keeps going forever. So this is n is equal to 0. This would be n. This is totally not in this course. I'm just showing you. This is something that you learn later on. This would be n is equal to 1. This is n is equal to 2. This is the exponent. All right? So if I said x plus 1 to the power of 4, now that is going to be a gong show to expand. All right? Because you're going to go x plus 1 times x plus 1 times x plus 1 times x. It's going to take a lot of work to do that. But Pascal's triangle says that that's n is equal to 3. This is n is equal to 4. So right away, and we do this, it used to be in Math 12, you could just go, I know the first term is going to be x to the 4. The second term is going to be x cubed, but I use these are my coefficients. Then it's going to be 6x squared, and then it's going to be 4x, and then it's going to be 1. That's the expansion of this in one step. Okay? So later on, it's called binomial expansion. And if you take Math 12 or calculus or university stuff, you will learn about that. It's a trick or a shortcut or whatever you want to call it as a way to expand binomials. We don't cover any of that in this class. But it's something, it's not just a useless triangle. It actually has applications in higher level math. Okay? We So we're going to skip to page 508, please. And in this class, we only study arithmetic. No, the first two were useful because they were arithmetic, but okay. So there's different types of sequences. An arithmetic sequence is adding a constant, all right? +2, +3. It can be negative constant, so -3. That's still adding, right? Because it's adding a negative. There's also a geometric sequence, which is multiplying, so ×2, ×1/2, etc. And then there's these non-arithmetic sequences, such as prime numbers. 2, you guys remember what a prime number is? 4 is not prime. 2 is prime. 2, 3, 5, 7, 11. But what is a prime number? Yes, the only factors are 1 and itself. You can't break them down anymore. Remember, we did that in the very first unit. There's the Fibonacci sequence. Can you figure out how you get the next number? Where do the numbers come from in the Fibonacci? You add the previous one. So 1 + 1 gives me 2. 2 + 1 gives me 3. 3 + 2 gives me 5. 5 + 3 gives me 8. 8 + 5 gives me 13. 13 and 8 gives me 21, and 13 gives me 34, and you can keep going. You just add the previous number. That's the Fibonacci sequence. You see this pattern in nature a lot, how a plant will grow in terms of, what am I trying to say? How fast it's growing, things like that. It shows up, shells growing is a common one that you see, but you can look that up. We don't study any of those. The only ones we're going to study are these ones, arithmetic, okay, where you add or subtract something. So this just kind of lines them out. Arithmetic is adding or subtracting. And this is math 10. This is what we're going to look at. Geometric is multiplying or dividing, which are basically the same thing. That's math 12. And then the other stuff is if you go to university. Well, if you take math in university, I guess I should say. All right. Now, there's a couple of types of sequences, finite and infinite. Finite sequence ends, okay? Specific number of terms, i.e. I'll say it stops. It has a last term. Last term, last term. It stops. Has a last term. The sequence ends, essentially. The first one, the last term is 28. The second one, the last term is 256. An infinite sequence goes on forever. All right, has an infinite number of terms, and they represent that by these 3 dots. So it continues forever. Okay. So what I would like you to do is questions 3 and 4, please.